Question 10, we've got the weight P on the table here, and that's 3 kilograms. So there's a normal reaction force here, and there's the 3G going down here. We do have some friction here because it does say it's a rough table, and we've got the tension of the string pulling it to the left. Now that tension there is connected to this weight Q, and Q is 2 kilograms, so I've got 2G going down and we've got tension pulling up. And when this is all let go, the whole thing happens so that this accelerates downwards here at 0.5 meters a second. So let's look at that to start with then. At Q, what's happening? So I've got 2G pulling it down, I've got the tension stopping it moving, and that equals its mass, which is 2, times by acceleration, which is 0.5. And so from that, I can figure out that T is 2G, take away 1, so that's 18.6 newtons. Okay, now let's look at what's happening at P. At P, we've got the tension pulling it this way, and we've got mu r pulling it backwards. And again, that will equal the mass times the acceleration. The tension we know is 18.6 because we just found it out. The normal reaction here, well, we can see it's 3G down, so it must be 3G there as well. And if we just rearrange that, we can find out that mu is, let's put a couple more decimal places on it to start with. So we've got 0.58163. Sorry, not 58163. So 582, if we round that to 3 significant figures. Now part C, there's 6 marks for this, so there's a lot of work to do. And that's the problem with these parts. People sort of think that they can do it in a line or two, and you can't. What the question says, it said it's going to go like this for 2 seconds. And the first thing I'm going to do is find out what happens in this 2 seconds of movement. So it starts at nothing. We're going to figure out what V is after 2 seconds. Because we do know what the acceleration is. The acceleration is 0.5. So V equals U plus AT. We can find out that after 2 seconds, it's going to be moving at 1 meter a second. But then the string breaks. Now, if the string breaks, the only thing that's working on this P, this mass here, is the friction. And the friction we knew was 0.582 times by R, which is 3G. And so now let's use a force equals mass times acceleration. And the mass is 3. So we get a new acceleration here. Our new acceleration is 5.7. I'll just tap that into the calculator. And so now the question's saying how long does it take to come to rest? So we've now got another Suvat equation. This time the U is this 1 here. So it's starting at 1 meter a second. We want to know how long it takes until it stops, with the acceleration being, again, be careful here, I've got minus 5.7 there, in that the acceleration is negative. And the T is what we're trying to find out. So again, a V equals U plus AT here, giving that T is going to be 1 divided by 5.7, which is 0.175 seconds. The end, the last bit says it was inextensible. If it's inextensible, that means the acceleration in both parts are the same. At the very beginning, we used this part here, that the acceleration was going to be the same in both of these two. yeah, look, we used the acceleration there and there. We could only do that because that was connected with an inextensible piece of string.